This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at implicit differentiation. And we'll take a look at our first problem. And get a little tablet to work here. There it goes. We got 3x squared plus 4y squared is equal to 9. The instructions say find dy dx by implicit differentiation. What we're going to do is we're going to take the derivative of everything where it's sitting. Because it's not so easy for us to solve this for y. We ended up with a plus or minus, and we haven't even looked at how in the world we handle a plus or minus. So we'll take the derivative of 3x squared, where it's at. We'll take the derivative of 4y squared, where it's at. And we'll take the derivative of 9. So we'll take the derivative of each term separately. Now we're taking all of them with respect to x. So the derivative of 3x squared gives us 6x. Now over here we're taking the derivative with respect to x, but this is y. Well, we take the derivative just like normal. So take the power, put it out in front, lower it by 1, so this becomes 8y. But since we're taking the derivative with respect to x, and this is really a y, we have to add on a y prime. And then derivative of 9 is 0. Now we want to solve for y prime, so we'll take the 6x to the right side. And we get 8y, y prime is equal to negative 6x. And then we'll divide both sides by what's in front of our y prime, which is 8y. So we'll divide both sides by 8y. So 8's cancel, those y's cancel, and we get y prime is equal to 6 and 8 reduce, negative 3x over 4y. And that's our answer. Let's take a look at another one. Got x to the third y plus y to the fourth x squared equals 5. Same instructions. So again, we want to take the derivative of everything where it's sitting. When I say everything, I'm talking about separated by pluses and minuses and equals. So we'll take the derivative with respect to x of x to the third y plus the derivative with respect to x of y to the fourth x squared, and the derivative with respect to x of 5. Well, these first two are product rules. X to the third will be a p, this will be our q. So p prime, the derivative of x to the third is 3x squared. For q prime, the derivative of y is 1, but we have to add on a y prime. Again, we're taking the derivative with respect to x, and that's y, so you take derivatives just like normal, but then you have to add on your y prime. Now most books will put dy dx there, and I prefer to use y prime because it's easier to use in algebra calculations. Phase 1 is going through and creating these videos, and then my second phase on these will be to put some of the theory and the proofs and everything in a separate video. Well, our formula is p prime q plus pq prime. P prime is 3x squared times q, which was y, plus p, which was x to the third, times q prime, which was y prime. Now we're going to do the same thing in this other one, and I might as well use p's and q's again. This will be p and this will be q. P prime here, derivative of y to the fourth is 4y to the third. But since we're taking derivative with respect to x and it's really y, we have to add on a y prime. And then q prime, the derivative of x squared is 2x. So again, our formula is p prime q plus pq prime. So we've got plus p prime, which is 4y to the third y prime, times q, which was x squared, plus p, which was y to the fourth, times q prime, which was 2x. And derivative of 5 gives us 0. Now let me double check that. So we got 4y to the third y prime times x squared plus y to the fourth 2x. Okay. Now I want to get everything over everything with the y prime on one side, everything else on the other side. So I'm going to take this to the right side, and I'll take this term to the right side. So we're going to have x to the third y prime plus 4, and I'm going to rearrange this. I'll put the x squared first, then y to the third, and then y prime at the end, equals, when I take the 3x squared y to the right side, becomes a negative 3x squared y. When I take this y to the fourth times 2x to the right side, becomes negative, and I want to rearrange it, so it's minus 2x y to the fourth. Just in alphabetical order. Numbers first. Well, our goal is to get a single y prime, and there's two ways of getting a single y prime. One of them is combine together like terms, and the other one is to factor it out. And we're specifically going to factor out the y prime. And that'll give us x to the third plus 4x squared y to the third equals negative 3x squared y minus 2x y to the fourth. Now our goal is to get the y prime by itself, so we'll divide both sides by what's behind our y prime. So we'll divide both sides by x to the third plus 4x squared y to the third. Do the same over here. And when we do that, this x to the third plus 4x squared y to the third cancels with this. Now over on the right side, I notice that everything has an x. So while I don't want to necessarily factor out all the GCF, because probably wouldn't be that beneficial to us in this case. Pulling out an x would be. So I'll factor an x out of the top, and that leaves us negative 3xy minus 2y to the fourth over, and I'll factor an x out down below, and that'll leave us x squared plus 4x y to the third. Well, the x is going to cancel, and we'll have negative 3xy minus 2y to the fourth over x squared plus 4x y to the third. And that's our answer. I got a feeling the book probably doesn't factor out it completely in terms of the GCF. Just we'll worry something will cancel away, it'll probably do that. Trying to see if I have room for this next one. I may not. Hard to say for sure. I'll go ahead and save this. Then start a new page. Implicit Differentiation, page 01.pdf. Okay, let's look at this one. So we've got e to the 7x minus y plus y squared equals 2x. As you can see, it'd be very difficult to solve for y, if not impossible. So implicit differentiation is really our only option on a lot of these. So we're going to take derivative of everything where it's sitting. So I'll take derivative of the e to the power, again with respect to x. I'll take the derivative of y squared with respect to x, and the derivative of the 2x with respect to x. Well, the derivative of e to a power is always e to the power, that doesn't change, times the derivative of the exponent. So take it times the derivative of 7x minus y. Now the y squared becomes 2y. Take derivative just like normal, but since we're taking derivative with respect to x and this really has a y, we have to throw in our y prime. And derivative of 2x is 2. Well, the 7x, the derivative of 7x gives us 7, minus the derivative of y is 1, but we have to add on a y prime, because it's y. Plus 2y, y prime equals 2. This is a distributive property. We're going to take e to the 7x minus y power, multiply times a 7, and times a negative y prime. So that gives us 7e to the 7x minus y, minus y prime e to the 7x minus y, plus 2y, y prime equals 2. Now we want to get everything with a y prime on one side, everything else on the other side. Doesn't really matter which side you take it to. I may go ahead and, well, I'll just take this 7 e to the 7x minus y to the right side. And then I'll flip these around because I don't want that negative first. So I'll put a 2y, y prime, minus y prime e to the 7x minus y equals 2 minus 7e to the 7x minus y. No particular reason why you can't put a negative first. I just didn't like how it looked. We want to solve for y prime, so we want to factor out a y prime. And that gives us 2y minus e to the 7x minus y equals 2 minus 7e to the 7x minus y. Now we want to get y prime by itself, so we'll divide both sides by what's behind our y prime. So we'll divide both sides by 2y minus e to the 7x minus y. Do the same thing on the right side. And those cancel. And we get y prime is equal to 2 minus 7e to the 7x minus y over 2y minus e to the 7x minus y. So we got y prime by itself. Now, recall our original problem. Our original problem was e to the 7x minus y plus y squared is equal to 2x. Now I could solve this for e to the 7x minus y. So I'll take the y squared over, and we've got e to the 7x minus y is equal to 2x minus y squared. So now I'll plug this into our problem. Everywhere we have an e to the 7x minus y, we're going to replace it with 2x minus y squared. So this becomes 2 minus 7 times 2x minus y squared over 2y minus 2x minus y squared. So again, everywhere in my problem where I had an e to the 7x minus y, I replaced it with 2x minus y squared. So then we get y prime equals 2, negative 7 times 2x is negative 14x. Negative 7 times negative y squared gives us a positive 7y squared. And we got 2y minus 2x plus y squared. Remember, when you have a negative in front of your parentheses, flip the sign of everything inside. And I doubt if they go much further in terms of simplifying that. I don't think there's much you can do. You could rearrange terms a little bit, but that's good enough as is. Assuming no basic algebra mistake, that's our answer. save that page. Time for my tablet to blow up, so I'll bring up another copy. There we go. Let's look at our next problem. Here we got the cube root of xy is equal to y to the fourth minus 7xy. Well, we want to take derivative of everything where it's sitting. So take the derivative with respect to x. And I'm going to write this, I don't want it radical form, so I'm going to write it as xy to the 1/3 power equals y to the fourth minus 7x. Oops, what am I doing? I was thinking about something else. Got The Walking Dead on TV, so I'm kind of halfway watching that while I'm doing this. Which isn't good. Okay, so plus, and then take derivative of negative 7xy. Okay, now over on this left side, this is a chain rule. We've got parentheses to a power. Chain rule specifically, it's applied to the general power rule. Take our power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, so we got 1/3 minus 1, times the derivative of what's inside the parentheses. Again, chain rule. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply times the derivative of what's inside the parentheses. Equals. The derivative of y to the fourth is 4y to the third, y prime. Now this one right here is the product rule. I'm going to let the negative 7x be my p, and I'll let my y be my q. Now, the negative 7, I went ahead and included it in with the p so I wouldn't have to worry about it, but you can put the negative 7 out in front if you want, and then take negative 7 times everything when you're done. Either way, it'll give you the same answer. So p prime, the derivative of negative 7x is negative 7. For q prime, the derivative of y is 1, but since it's y, we have to add on a y prime. Because again, we're taking the derivative with respect to x. So then our formula is p prime q plus p q prime. So we got plus p prime, which is negative 7, times q, which is y, plus p, which is negative 7x, times q prime, which was y prime. Now this over here is also the product rule. This would be my p, and this would be my q. P prime, the derivative of x is 1. For q prime, the derivative of y is 1, but we have to add on a y prime. Because again, whenever you're taking derivative with respect to x and it's really y, you have to add that on. Okay, so we got 1/3 xy, 1/3 minus 1 gives us negative 2/3, times p prime, which is 1, times q, which is y, plus p, which is x, times q prime, which is y prime. Equals 4y to the third y prime minus 7y minus 7x y prime. Now I want to take that xy to the negative 2/3, put it down in the denominator. And this is going to go up on, well, we won't put it up on top yet, but so this will be 1 over 3 times xy to the 2/3 times y plus x y prime equals 4y to the third y prime minus 7y minus 7x y prime. Okay. We're going to go ahead and get rid of parentheses. So I'll take this fraction here, and I'll multiply it times the y and multiply it times the x y prime. So that's going to give us y over 3xy to the 2/3 plus x y prime over 3xy to the 2/3 equals 4y to the third y prime minus 7y minus 7x y prime. Well, next thing we want to do is get rid of fractions. We'll multiply everything by the LCM of all our denominators. Well, we have two denominators that are both the same, so our LCM is just 3 times xy to the 2/3. So that's what we'll multiply everything by. So multiply times our first fraction here. Multiply times our second fraction. And multiply times everything on the right side. Now when I multiply times everything on the right side, basically we're just going to put it next to each one of these. So I'll go ahead and do that. So we've got 4y to the third y prime times 3xy to the positive 2/3 minus 7y times 3xy to the positive 2/3 minus 7x y prime times 3xy to the positive 2/3. Well, this cancels with that, and this cancels with that. So on the left side, I'm left with y plus x y prime equals, and over on the right side, 4 times 3 is 12. So I got 12 y to the third y prime x y to the 2/3 minus 7 times 3 is 21 y and xy to the 2/3. And 7 times 3 here gives, so we get negative 21 x y prime xy to the 2/3. Lots of algebra here, so hopefully I'm not making any kind of algebra mistake. I don't see any. Okay. Well, now we want to solve for y prime, so I want to get everything with y prime on one side, everything else on the other side. And so I'll take this over to the left side, z has a y prime, and I'll take this over to the left side, z has a y prime. And I'll take the y over to the right side. So I'm going to have x y prime and minus 12 y to the third y prime xy to the 2/3, and bring this over, and this becomes plus 21 x y prime xy to the 2/3 equals, and this stays here, and we'll bring the y over, so we got minus y minus 21y xy to the 2/3. Okay, let me double check everything here as much as I can. Okay, now we want to factor out the y prime, and that's going to leave us x minus 12y to the third xy to the 2/3 plus 21x xy to the 2/3 equals negative y minus 21y xy to the 2/3. Now we're going to divide both sides by what's behind our y prime. This x minus 12y to the third xy to the 2/3 plus 21x xy to the 2/3. So I won't write that step out because I'm running out of time, space. So we got negative y minus 21y xy to the 2/3 over x minus 12y to the third xy to the 2/3 plus 21x xy to the 2/3. And that's probably our answer, assuming no basic algebra mistakes. Now, sometimes books will take this further. Remember what our original problem looked like. We call the cube root of xy is equal to y to the fourth minus 7xy. Well, you could take this problem further. Negative y minus 21y, and then this right here I can rewrite as the cube root of xy to the second power. Because the 2, you can put it on the outside of parentheses always, and then that would leave us 1/3, which is the cube root, over x minus 12y to the third cube root of xy squared plus 21x, and then this would be the cube root of xy squared again. So we could go through if we wanted to and replace all the cube root of xy's with y to the fourth minus 7xy. That'd give us negative y minus 21y times y to the fourth minus 7xy squared over x minus 12y to the third y to the fourth minus 7xy squared plus 21x y to the fourth minus 7xy squared. Is that any simpler than the one I actually circled up above? Probably not. But it does eliminate the cube root, the radical portion of it. So if that bothers you, then you can put it into this form. Save that. And start a new page. Okay, let's look at this one. Got 2 tangent x cosine y is equal to 3. And we want to find the derivative of everything where it's sitting. Now when I say everything, notice how there's no pluses or minuses on anything on the left side here. This is considered one grouping. So we're going to take the derivative of it with respect to x. So 2 tangent x cosine y, and we'll take the derivative of the 3 with respect to x. Now over on the left side, that 2 I could put out in front, or I could include it in. It doesn't matter. I'll include it in. The 2 tangent x will be my p, and then the cosine y will be my q. So p prime, the 2 carries down. The derivative of tangent is secant squared. For q prime, well, the derivative of cosine is negative sine. But since we're taking the derivative with respect to x and it's really y, we have to add on our y prime. So we've got our p prime q plus p q prime. So p prime is 2 secant squared times q, which was cosine y, plus p, which was 2 tangent x, times q prime, which was negative sine y, y prime. And derivative of 3 would give us 0. Okay, well, we want to get everything with a y prime on one side. So I'm going to go ahead and take this grouping here over to the right side. Now this is really a negative 2 tangent x sine y, y prime, because it's negative here. So when I take it to the right side, it becomes positive. So we got 2 secant squared x cosine y is equal to 2 tangent x sine y, y prime. Now our goal is to get to y prime by itself, so I divide both sides by what's behind our, or in front of our y prime. So we'll divide both sides by 2 tangent x sine y. And 2 tangent x sine y, y prime. Now there's some items we just assume that everything's okay when we're doing calculus. obviously you can't divide by this if sine y is equal to 0 or tangent x is equal to 0. So this would put stipulations on what x and y can be. That wouldn't necessarily be the stipulations up here, but for purposes of this class, we pretty well we ignore that. Later on, you address that. Tangent x's cancel, the 2's cancel, and the sine y's cancel, and we get y prime equals 2's cancel here, and secant squared. Secant is 1 over cosine, so that would be 1 over cosine times 1 over cosine, because secant squared is secant times secant, times cosine y over tangent x times sine y. I'm going to flip that around. I'll put y prime over here. Now, tangent is sine over cosine. So we'll have 1 over cosine times 1 over cosine over tangent is sine over cosine. So sine x over cosine x times cosine y sine y. Well, I can, if you got a single fraction downstairs, you can flip it and multiply it times your top part. So sine over cosine becomes cosine over sine, and I'll multiply it times the top. Now cosine y over sine y. Cosine over sine is cotangent, so this is cotangent y. Over here, this cosine cancels that cosine. And so we got y prime is equal to 1 over sine times 1 over cosine, x of course, times cotangent y. Well, 1 over sine is cosecant, so this becomes cosecant x. 1 over cosine x is 1 over cosine is secant, so that's secant x. And then our cotangent y carries down. And that's our answer. Usually simplified form for trig means, if possible, get rid of the fraction and get a single trig function, whatever it might be, like this. And of course everything has to be multiplication if we can get it there. Let me grab a drink here. No, look at this one. Do I have room? Yeah, probably. I probably have room. So we've got natural log of x squared y to the third plus 2x equals 5. Now the derivative of a natural log is 1 over whatever's inside your parentheses times the derivative of what's inside your parentheses. Well, the derivative of this would be the product rule. Just, it wouldn't be horrible, but there's an easier way. Now here we have log of something times something. Well, multiplication becomes addition. So I can rewrite this as natural log of x squared plus natural log of y to the third plus 2x equals 5. Now remember with logs, if you have a log of something to a power, you can take power and put it on front of the log. So this becomes 2 natural log of x plus 3 natural log of y plus 2x equals 5. Well, now we want to take derivative of everything where it's sitting. So I'll take derivative of 2 natural log of x, and I'll take derivative, all of this is respect to x, take derivative of 3 natural log of y, and the derivative of the 2x, and the derivative of the 5. Well, the 2 just carries down. The derivative of natural log of x is 1 over x. This one, the 3 carries down. And the derivative of natural log of y is 1 over y, but again, we have to add on our y prime. Anytime you're taking derivative with respect to x and it's really y, or a different variable, you have to throw on the dy, dy over dx, or just y prime. Plus, derivative of 2x is 2, and derivative of 5 is 0. So that gives us 2 over x plus 3y prime over y plus 2 equal to 0. Now we're solving, and anytime you're solving anything in math, you always get get rid of parentheses first, but then you get rid of fractions. And it's always the same way. We multiply everything by the LCM of all our denominators. We got x and y, so our LCM would be xy. And that's what I multiply everything by. So multiply times my first fraction, multiply times my second fraction, multiply times the 2, and I'll also multiply times the 0, though that doesn't ever go anywhere. These x's cancel here, and I got 2y plus those y's cancel, and we got 3x y prime plus 2xy equals 0. Now we're solving for y prime, so we want to get everything with y prime on one side and everything else on the other side. So I'm going to take the 2xy to the right side and take the 2y to the right side. So I get 3x y prime is equal to negative 2y minus 2xy. Now try and get the y prime by itself, so we'll divide both sides by what's in front of our y prime, which is 3x. So we'll divide both sides by 3x. And we get y prime is equal to negative 2y minus 2xy over 3x. And assuming no basic algebra mistake, that's our answer. Excuse me. Haven't had any pop since this morning, and I'm kind of feeling it. Probably not the smartest thing to make a math video. I'm halfway, not asleep, but not as alert as I need to be. Okay, let's look at this one. Find dy dx by implicit differentiation and then evaluate the derivative at the given point. Okay, so let's work this problem. So we got 2x minus y to the third power equals x squared plus y minus 13 1/4. Okay. Now remember our steps. This says evaluate the derivative at a given point. In past lessons, we referred to this as finding the slope of the tangent line at that point. That's the same as evaluating the derivative at that point. They give you the same result. Now, our first step was to find our derivative. Now, in this case, we want to use implicit differentiation. So I'm going to take derivative of everything where it's sitting. So I'll take the derivative of 2x minus y to the third. I'll take the derivative of x squared, the derivative of y, and the derivative of negative 13. Well, here we got parentheses to a power. So this is the chain rule, the general power rule. It says you take your power, put it out in front. What's inside the parentheses remains as is. You lower your power by 1, and then you multiply it times the derivative of what's inside your parentheses. Then equals, the derivative of x squared is 2x, plus the derivative of y is 1, but we have to add on our y prime since it's y. And derivative of negative 13 is 0. So we got 3 times 2x minus y squared times, then the derivative of 2x is 2. The derivative of negative y is negative 1, but we have to add on our y prime. Equals 2x plus y prime. So we got 3 times 2x minus y squared times 2 minus y prime equals 2x plus y prime. Now we need to get this y prime out of this parentheses, and how we'll do that is with the distributive property. I'm going to take this 2x minus y squared, I'll multiply it times the 2, and I'll multiply it times the negative y prime. So we've got 2x minus y squared times 2 plus 2x minus y squared times negative y prime equals 2x plus y prime. So that gives us 2x minus y squared. And then this negative I'll go ahead and put out in front. So we got minus 3, and I'll put the y prime out in front too. Minus 3 y prime, 2x minus y squared equals 2x plus y prime. Let me double check this. 2, and then take that and that. Okay, yeah, it looks right. Now we're solving for y prime, so we'll get everything with y prime on one side. So I'll take this negative 3 y prime 2x minus y squared to the right side, and I'll take this 2x to the left side. So I'm going to have 6 times 2x minus y squared minus 2x equals y prime plus 3 y prime 2x minus y squared. Now we're solving for y prime, so I want to factor our y prime out of the right side. When I do that, this becomes 1 plus 3 times 2x minus y squared. And to get y prime by itself, we're going to divide both sides by what's behind our y prime. So we'll divide both sides by 1 plus 3 times 2x minus y squared. Go. When I do that, this 1 plus 3 2x minus y squared cancels with that, and we're left with y prime equals 6 times 2x minus y squared minus 2x over 1 plus 3 times 2x minus y squared, assuming no basic algebra mistake. Well, now, step 2. We want to change y prime to m. I'm going to put m there because that's what they're asking when they say evaluate derivative. And we'll plug in our point. Our point was 1, 4. So we're going to put the 1 in for the x, and we'll put 4 in for the y. So this is 6 times 2 times 1 minus 4 squared. And I'm just getting all messed up with my brackets and parentheses here. Let me just keep it simple. Okay, 6 times 2 times 1 minus 4 squared minus 2 times x, which is 1, over 1 plus 3, and then 2 times 1 minus 4 squared. 2 times 1 is 2, minus 4 is negative 2. Negative 2 squared is 4. Minus 2 over 1 plus 3, and 2 times 1 is 2, minus 4 is negative 2. Negative 2 squared is 4. Let's see, 24 minus 2, and 1 plus 12. And I'm going to holler at my son. Eric, let the dog out. I hear her snorting is what she does when she has to go to the bathroom. So assuming no basic math error, our value of our derivative is 22 over 13. So let me save that. I was wondering what to do. I was going to have to tell you I was going to be right back, because otherwise she'll make a little mess in the utility room. Okay, let's look at our next problem. Let's take a look at this one. So we've got 3x squared. So 3x squared minus y equals negative 7 plus y to the third at the point 1, 2. Now it tells us to find the equation of the tangent line using implicit differentiation. Now if you remember our steps for that, our first step was to find derivative. So we're going to take derivative of everything where it's sitting, respect to x. So we'll take derivative of 3x squared, take the derivative of negative y, the derivative of negative 7, and the derivative of y to the third. Well, 3x squared becomes 6x. The derivative of negative y is negative 1, but we have to add on our y prime. Derivative of negative 7 is 0. The derivative of y to the third is 3y squared, and we add on our y prime. So we've got 6x minus y prime equals 3y squared y prime. Now I want to get everything with y prime on one side, so I'll take the negative y prime to the right side. So we get 6x equals 3y squared y prime plus y prime. Now we want to factor out a y prime, and that'll leave us 3y squared plus 1. And we're trying to get y prime by itself, so we'll divide both sides by 3y squared plus 1. So then these 3y squared plus 1's cancel. And we end up with 6x over 3y squared plus 1 equals y prime. Step 2. Change our y prime to m, our notation. And we're going to plug in our point. Our point was 1, 2, so plug 1 in for x and 2 in for y. So we're going to have 6 times 1 over 3 times 2 squared plus 1, which gives us 6 over 2 squared is 4 times 3 is 12 plus 1 is 13. Step 3. Step 3 was to plug in the given point for x and y and the m we just found into y equals mx plus b and solve for b. Well, y was 2, m was 6/13, and x is 1, and then plus b. Okay, so we got 6/13 times 1 gives us 6/13 plus b, and take that over to the left side, becomes a negative 6/13, and that gives us 20/13 for b. Mixed number, I took 2 times 13 gave us 26, plus a negative 6 gives us 20. And we can't forget step 4. Step 4 says to actually write our answer. We found m was 6/13 in step 2, so plug in 6/13. And we found b was 20/13, so plug that in. And that would be our equation of the tangent line. Let's save that. Excuse me. And let's take a look at our next problem. Let me grab a drink here. Number 9. Got y equals the square root of x to the third, x plus 5, or x to the third times x plus 5, times x plus 7. And it tells us x is greater than 0. You need that there for the proper rule we're going to apply here. It says find dy dx using the logarithmic differentiation. Well, we got a property from college algebra that says you can take natural log of both sides. So I'll do that. Take the natural log of y, and I'll take the natural log of this square root. Now I'm going to go ahead and rewrite that into fractional power form, rational exponents. The square root is the 1/2 power. Well, why would we want to do this? Well, because our properties of log says if you got log of something to a power, you can take the power and put it out in front. So this becomes natural log of y is equal to 1/2 natural log of x to the third times x plus 5 times x plus 7. Now we can go even further. Now that just eliminated our radical, which is kind of cool. But we can go further. What's inside the brackets here is multiplication. X to the third times x plus 5 times x plus 7. Remember, multiplication from college algebra becomes addition. So this becomes 1/2 natural log of x to the third. Now the 1/2 has to be out in front of all of your natural logs, or outside and multiplied by everything. So we've got plus 1/2 natural log of x plus 5 plus 1/2 natural log of x plus 7. And all of a sudden we eliminated that product rule we would have to use. Last thing we can do, see the 3 that's our power on the x, we can put that out in front. So this becomes natural log of y equals 3/2 natural log of x plus 1/2 natural log of x plus 5 plus 1/2 natural log of x plus 7. And now we're ready to take derivative of everything we're sitting. So we'll take derivative with respect to x of natural log of y. We'll take the derivative with respect to x of 3/2 natural log of x. The derivative with respect to x of 1/2 natural log of x plus 5. And the derivative with respect to x of 1/2 natural log of x plus 7. Okay, well, the derivative of natural log of something is 1 over whatever follows the natural log. So the derivative of natural log of y is 1 over y, but since it's y, we have to throw on a y prime. Over on the right side, the 3/2 remains. The derivative of natural log of x is 1 over x plus 1/2. The derivative of natural log of x plus 5 is 1 over x plus 5 times the derivative of x plus 5. Chain rule. Anytime you have more than a single x here, you have to do this. Plus 1/2 times the derivative of natural log of x plus 7 is 1 over x plus 7 times the derivative of the x plus 7. Same thing, chain rule. Anytime you have more than a single x here, your derivative of natural log of something is 1 over whatever's inside the parentheses times the derivative of what's inside the parentheses. So we got 1 over y prime, and that gives us 3 over 2x plus, now the derivative of x plus 5 is 1, so that basically drops away. So this is 1 over 2 times x plus 5 plus 1 over 2 times x plus 7. Again, the same. The derivative of x plus 7 is 1, so that drops away. Well, I want to, wonder why my screen went green. There it goes. That was weird. Okay, I'm going to multiply everything by y. So I'll multiply this side by y, because I'm trying to get y prime by itself. And I'll multiply the other side by y. There we go. Well, when I do that, these y's going to cancel here, and we got y prime by itself equals, and now y, remember, y is equal to all this. So the square root of x to the third times x plus 5 times x plus 7. So we can plug that in. So x to the third, x plus 5, and x plus 7. Now, what's inside the parentheses, we want to merge these into a single fraction. So we need to get a common denominator. Well, they all have 2, so that has to be in our denominator. This one is a single x, so that has to be in there. X plus 5 and x plus 7. So that's going to be our common denominator. There we go. Okay, let's look at our first fraction. It had 2, it had the x. The 2 and the x are still there. The new thing down below is the x plus 5 and x plus 7. So we have to put that up on top. Whatever new item you see downstairs, you have to put up on top. The mathematical rule on that is whatever you multiply by the bottom, you have to multiply by the top. Now this next one. Had the 2, had the x plus 5. Well, the 2 is still there, the x plus 5 is still there. The new items downstairs are the x and the x plus 7. So we multiply that times the top. Now our last fraction, it had a 2, had an x plus 7. The 2 and the x plus 7 are still there. The new item down there is the x and the x plus 5. Okay, so we got square root. Now I could bring a pair of those x's out, but I won't do that. Not unless... Actually, I will at the end. Looks like I can cancel something. Okay, well, these all have the same denominator now, so I'll merge together the top parts. So I got 3 times x plus 5 times x plus 7 plus x times x plus 7. The ones drop away, plus x times x plus 5, all over 2x, x plus 5, x plus 7. Now this seems like a lot of work, and it is, but you'll find you'll do a lot more work if you don't use these log properties. And not all come out nasty like this either. Okay, so we got square root. Actually, let me bring an x out, because there's 3 x's here, so that leaves me a single x in here. Then x plus 5, x plus 7. And here I got 3 times, I won't show all the steps because I'm running out of room here, x squared plus 12x plus 35 plus x squared plus 7x plus x squared plus 5x all over 2x, x plus 5, x plus 7. And so I got x, square root of x, x plus 5, x plus 7. And then up on top, multiply that through, and I got 3x squared plus 36x plus 105. Combine together these like terms, x squared plus x squared is 2x squared.
Avast virus database has been updated.
Go away, Avast. Okay, 7x plus 5x gives us 12x over 2x, x plus 5, x plus 7. Now notice I put the square root up on top, because if I were to put that in fraction form, that's like square root over 1. So that's how where it would go if I multiplied it through. Well, notice here I have an x and here I have an x, so these x's are going to cancel. So we're going to be left with the square root of x times x plus 5 times x plus 7 times 3x squared plus 2x squared is 5x squared. 36x plus 12x is 48x plus 105 all over x times x plus 5 times x plus 7. Now it doesn't look like I can factor that 5x squared plus 48x plus 105, so this would be our answer. Let me save that. And let's look at our next problem. We got y is equal to x to the x plus 2 power. X is greater than 0. And it tells us to use log differentiation again. So we're going to take natural log of both sides. So we got natural log of y equals natural log of x to the x plus 2. Now, what would tell me to use this if the instruction didn't specifically tell you is the fact that we have a variable up in our power. You can't have that. When we got the our very basic differentiation rule we looked at, x to a power, the power had to be all numbers. So x to the third power, x to the 1/2, or something like that. You can't have x to an x. Well, the reason why we take natural log of both sides is we can get that exponent out of there now. We can take the x plus 2 and put it out in front of the log. And now we're ready to take the derivative of everything where it's sitting. So we'll take the derivative with respect to x of natural log of y. And we'll take the derivative with respect to x of x plus 2 times natural log of x. Product rule on the right side. We got this times this. So p is x plus 2 and q is natural log of x. P prime, the derivative of x plus 2 is 1. Q prime, the derivative of natural log of x is 1 over x. So this will be p prime q plus p q prime. Now back over the left side, natural log of y. That's 1 over y, but we have to add on a y prime because we're taking the derivative with respect to x and this really has y. Now over on the right side, we got or p prime, which is 1, times q, which is natural log of x, plus p, which is x plus 2, times q prime, which is 1 over x. Well, we want to multiply both sides by y. And that gives us natural log of x plus x plus 2 over x. Over here, these y's going to cancel. And we end up with y prime equals y. Now remember what our y originally was. Our y originally was x to the x plus 2 power. So we can plug that in now. So x to the x plus 2 for the y times natural log of x plus x plus 2 over x. I'm guessing that they probably don't want us to merge these together. They'd probably leave it in this form. But we could get a common denominator if necessary and merge everything together. It might not work out too bad if I did that. Let me do it just for fun. Okay, so we got x to the x plus 2, and then I will get a common denominator, so this would be x natural log of x over x plus x plus 2 over x. So we get y prime is equal to x to the x plus 2 times x natural log of x plus 2 over x. And put that on up on top in the numerator. So we got x to the x plus 2 times x natural log of x plus 2 over x to the first. I don't think I simplified this in the class. If you got x to a power over x to a power, you subtract the exponents. So that's x plus 2 minus 1. So we have x to the x plus 2 minus 1 times x natural log of x plus 2. The x, the first, disappears down there, which then gives us 2 minus 1 is 1. So we got x to the x plus 1 times x natural log of x plus 2. That one actually worked out kind of decent. It eliminated the fraction when we merged it together. Do I have room for the next one? Probably do. In case you're wondering why they're putting those conditions on the x, some of these, when you have natural log involved, you can't have natural log of 0 or natural log of a negative number. So that's why they're putting them there. Okay, so we got y is equal to x minus 3 to the natural log of x power. Well, we'll take the natural log of both sides again. And of course, the reason why we do that is then from college algebra, if we have a power, you can put it out in front of your log. So I'll put the natural log of x out in front. And we'll have this. And now we take derivative of everything we're sitting. So take derivative with respect to x of natural log of y. The derivative with respect to x of natural log of x times natural log of x minus 3. Now over on the right side, this is the product rule. So this natural log of x is p, the natural log of x minus 3 is q. P prime, the derivative of natural log of x is 1 over x. Q prime, the derivative of natural log of x minus 3 is 1 over x minus 3 times the derivative of x minus 3. Again, the chain rule. Anytime you have natural log of something more than a single x, it's always, the derivative of it is always 1 over whatever's inside of parentheses times the derivative of what's inside of parentheses. But the derivative of x minus 3 is 1, so q prime is just 1 over x minus 3. So we'll have p prime q plus p q prime. Now back to our left side. The derivative of natural log of y is 1 over y, but since it's y, we have to throw on a y prime. Equals p prime, which is 1 over x, times q, which was natural log of x minus 3, plus p, which is natural log of x, times q prime, which is 1 over x minus 3. Multiply both sides by y again. And this is natural log of x minus 3 over x plus natural log of x over x minus 3. Y's cancel here. And then we'll have y prime is equal to y, which y was this right here. So we can plug that back in. So x minus 3 to the natural log of x power times natural log of x minus 3 over x plus natural log of x over x minus 3. I guess I'll merge these into a single fraction. I'm guessing they probably leave the answer right here, but you never know. So this is, as long as I have room. When I run out of room on my tablet, I'll call it good. Now I'll skip a few steps. Basically, our common denominator is x times x minus 3. So this top part here becomes x minus 3 times natural log of x minus 3 plus x times, I guess I'm not skipping any steps, am I? Then x natural log of x, which gives us x minus 3 to the natural log of x times x minus 3 natural log of x minus 3 plus x natural log of x all over x times x minus 3. Now, this is x minus 3 to the power, and this is x minus 3 to the first power. I could subtract those, and it might simplify it a little bit. Basically, it would look like this. You'd have x minus 3 to the natural log of x minus 1 times the x minus 3 natural log of x minus 3 plus x natural log of x all over x. They might do that. It's hard to say. Every book does it different. How far they go and where do they stop at. Be nice if there's consistency. But then I guess every calc book would look the same and it'd be kind of a boring world. Okay. I think that was the last problem. Now, assuming no basic algebra mistake, that's implicit differentiation. So let me stop the recorders.